Hi everyone, welcome to my channel Ravi Babu Edu Tech. Today we are going to cover Uni Junction transistor. Actually, it is a very familiar concept about Uni Junction transistor because it is one of the best application which is generating pulse. Such pulses are sawtooth pulse generator or wave generator. Okay, so it is going to generate as sawtooth pulse generator as well as switching pulse generator. So such kind of waves are generating by the UJT. So this is what how to generate these two things, how it is going to generate, and there is a circuit that we'll see now. So basically it has a 3-terminal device. It has a 3-terminal semiconductor device, that is emitter, base, and in this base, that is base 2 and base 1. Okay, these are the 3 terminals, emitter, base. In that base there will be 2 types, one is base 2 and base 1. So these are the 3 terminals. Okay, now between these two, which is going to draw the structure of UJT. In that we will see now. So here this is ohmic contacts, that is this is base 2, another ohmic contacts which is connected electrically, and this is base 1. Okay, now emitter which are placing nearby base 2, that is what here. This is also contact, this is emitter. Okay, this is going to nothing but aluminum p-type bar, and these two are nothing but ohmic contacts, silicon bar. Okay, this is nothing but ohmic contacts, and these two, base 1 and base 2, are nothing but silicon bars. Now this is n-type. Okay, now the combination of these two, p-type and n-type, is nothing but p-n junction. So this is what structure of UJT. Okay, now the symbol of UJT is nothing but this is B1 and this is B2, and now this is nothing but emitter. Okay, see the symbol of just little bend is there, that is indicates arrow. Now why it is indicate arrow is nothing but the conventional current flows from emitter to base 1, that is what the direction indicates. So this is the symbol of UJT. Okay, so this is the symbol of UJT, right? Now look at the equivalent circuit of this UJT. Okay, based on the equivalent circuit, we are going to discuss about operation. Equivalent circuit of UJT. See, before going to draw the equivalent circuit, let us recall about structure. See, this is a ohmic contacts and this is the emitter. Okay, so this can be written as what? PN junction diode. So this is PN now, so it just write as PN. that is diode. Okay, this is anode and this is cathode. Generally, as you know, this is what PN junction diode. Okay, now then this is two ohmic contacts are right, that is nothing but resistance. So here and one more resistance, this is base 1 region and this is base 2 region, and this is nothing but RB1, sorry, B2. Okay, and this is RB1. Okay, so this is the middle point of diode, and this is what emitter. Okay, so this is the equivalent circuit of UJT, right? Now based on this circuit we are going to applying the voltage. Now between these two, base 1 and base 2, you are applying what? VBB voltage, and then this voltage only dropping, which is going to drop across here VB2 and here VB1. Now this is what? Variable resistor. Okay, variable resistor. At this variable resistor, the drop across what? VB1, right, which is applied by the total voltage. Now in this region, if you going to apply voltage, what will happen? That will see now. Okay, there are three cases. One is with the emitter voltage is open, what will happen in this circuit? If applied positive voltage, emitter voltage, then what is the circuit? If you apply negative voltage, what will happen? That is the three cases which are going to looking, right? Yeah. So let me draw one more circuit that is same. Now between I am going to apply voltage. Case 1 with emitter voltage open, what will happen? Between base 1 and base 2, if you apply voltage, this is positive terminal and this is negative terminal which is connected base 1, and the positive terminal which is connected to base 2. This is what? Total VBB. Okay, now the drop across variable resistance, this one, that is what? VB1. Okay, here this is open circuit, VE is equal to 0, right? Now when VE equal to 0, then what's the drop across here? That is VB1. So that is intrinsic standoff ratio. Intrinsic standoff ratio is given by eta, that equal to what is? RB1 by RB1 plus RB2, because when current is, emitter current is 0, because here between this and this one, that is, this is nothing but VD. Okay, and voltage drop across VD, voltage diode voltage, and then drop across here VB1. Okay, now in this case, that is IE is 0 because emitter voltage is open. So because of this reason, there is no current between diode voltage and then drop across VB1. So that because of this reason, what is your intrinsic standoff ratio is eta equal to RB1 by RB1 plus RB2. Okay, when current is, emitter current is 0. Now at the time this value is very high, VB1 voltage. Okay, in that case I want to calculate here VB1 drop across RB2. So what's the, what RB1 here? Voltage drop across RB1. What's the value? We have to apply voltage divider rule between RB1, B1 and B2. Okay, we have to apply voltage divider rule. Why am I applying voltage divider rule? Because I need to calculate what is the value of VB1 at this resistor. Okay, so applying voltage divider rule across VB1. Then so this one VB1 equal to, so the drop across here VB1 equal to total voltage, that is VBB, the drop across variable resistance, that is RB1 divided by total resistance, that is RB2 plus RB1. Okay, so this is the equation for voltage divider rule between these. So because of to find this value of VB1 across this variable resistor, because of this value we are applying voltage divider rule. Then the drop across VB1 equal to total voltage divided by, that is into RB1 divided by total resistance. That is the expression for this value. Okay, it's all about calculating what? When VE equal to 0. At the time, what is the drop across here? For that purpose only we are applying voltage divider rule. Okay, now when current equal to 0, what is the expression for eta? That is RB1 by RB1 plus RB2. Now from this expression, VB1 equal to VBB into, what is the expression of this? That is eta. That is what? Okay, so this is the expression for VB1, the drop across here, VBB into, that is eta value. Okay, that is the expression for in this. Now what is the total resistance between base 1 and base 2? That is RB equal to RB1 plus RB2. So this is the expression for the drop across RB1 plus RB2, that is the total resistance of base. Okay, now so this is the when it is happen, when empty voltage is open. So this is the condition. In that case, when empty voltage is open, what is operation occurs? This voltage is dominating. Okay, this voltage is dominating in this voltage, empty voltage, because empty voltage is 0. Now in that case, here when empty voltage is 0, this VB1 is high. That is, in that case, VE is less than VB1. Hope you understand. When VE is less than VB1, then in that case, what is UJT? Is off condition. When UJT is in off condition. Okay, because why it is off condition? See, this is positive and this is negative. So VB1 is maximum. If VB1 is maximum, so what about here? This is negative. So plus minus, here plus, here minus. So what will happen? This diode becomes off condition. Okay, so because of off condition, here no current will flow. Okay, so for that reason, what is diode? That is UJT is off condition. Okay, this is what case 1. So here when it is off condition, V is 0 and then it is VB1 is maximum. Now look at case 2. Now look at case 2. When apply forward voltage at emitter, that is VE, then what the circuit behaves. When reaches points on voltage to the diode, when reaches positive voltage in diode, let me draw one more circuit for understanding. So this is voltage or resistance RB1, and this is positive and negative which is connected to B1. Now I am applying emitted voltage, that is VE. Now this is becomes VD, and here the drop across here VB1. Okay, and this is RB2 and this is RB1, and this is what VBB, plus and minus. Okay, now when emitted voltage increases slowly, when reaches points on voltage, emitted voltage, then diode gets on condition. When diode gets on condition, then what will happen? It starts current flowing through this direction. Why? Because when diode gets on condition, this from P region holes are entering into N region. Okay, hope you understand here. So this is the P type and this is N type. When diode gets on condition, these holes are moving this direction. Okay, then when holes are moving this direction, holes are goes to here. So this is positive terminal. So RB2 repels each other. Okay, RB2 pushing back. So these holes move towards RB1. Okay, attract with negative. Hope you understand. These holes entering into P region to N region. These RB2 pushing back. These holes move towards this region. So because of this region, it increases current. That is, IE current is increases when voltage VE increases. Okay, when voltage, emitted voltage is increases, IE current increases. Then what about VB1? VB1 decreases. Okay, so this is the condition. When emitted voltage increases, IE current increases. When IE current increases, what about here? The drop across RB1 decreases. That's the condition. Okay, so in this region, maximum current flow through this RB1, that is regenerative current, which is provided by the UJT. IE current is regenerative current, which is provided by the UJT. Okay, high amount of current which is provided. That is a major advantage of this circuit, right? Now so further, in that case, now what is drop across here? That is what is the peak voltage now? In that case, what is VE equal to this voltage plus this voltage, right? So VE is nothing but, also can be written as VP, that equal to VD plus VB1, that equal to VD plus, what is VB? Already we know, that is eta into VBB. Okay, this is what VP value. So this is the voltage drop across diode as well as RB1. In RB1, there is nothing but eta into VB1. Okay, so this is the expression, right? Now case 2, that is case 3. When emitter voltage is negative, then what will happen? When emitter voltage is negative, then UJT is off condition. When UJT is off condition, then current V is negative voltage, emitter current is decreases. When emitter current decreases, UJT is off. That is this condition, right? So at the time VB1 is increases. So that is what during negative half condition. So this is about three cases how it is going to operate as UJT. Now let's see characteristics of UJT. Between emitter voltage and current, emitter current. Okay, in this case, when initially with emitter voltage 0 at the time, it starts from like this. Okay, when it reaches this point. Okay, now from this region, when emitter voltage is 0, so that the curve starts from this region to this region. Okay, now when emitter voltage is applied positive voltage, then it starts increasing current like this up to this point. Okay, this is peak voltage. This is peak voltage, that is VP, and this point is nothing but IP. Okay, then when emitter voltage is increases, then it starts current increases like this. Okay, thereafter this is point valley. Then again it will starts like this. When it reaches emitter voltage is certain voltage, then that becomes saturated. Okay, that is saturated. This is IV. Okay, this point is IP and this point is IV. Okay, and here this point is nothing but valley voltage. After that, this region between this point and this point, that is nothing but saturation region. Between this point and this point, this is what negative resistance region. So this UJT works under negative resistance region. That is a major advantage of in this. Okay, between this point to this point, current will increases because emitter voltage is applied positive voltage, so that current will rise. Thereafter reaches to the value point, then thereafter from this value point to this point, that is saturation region, when it reaches maximum voltage of VA. Okay, that is the case how it's happened. Now here in this region between this point, this region is nothing but cutoff region. In this region current is 0. Okay, between this point peak voltage and the value voltage, between this region, that is current is maximum. That is what this one, negative resistance existence. Okay, so this is what characteristics of UJT. Now applications where these UJTs are going to uses. First one is switching devices, which is used in switching devices. Then timing control, then it is used in sawtooth wave generator, and it is used in UJT relaxation oscillator. So first one is what? Switching devices, timing control, and sawtooth wave generator, and finally UJT relaxation oscillator. Even phase control, it is also capability to control the phase. So this is the nothing but UJT, Uni Junction transistor. Hope you understand. Thank you very much.